Welcome back, children. Myself Rajita. Today I'm one of the topic is functions. So before I'm going to start functions, what is the actual definition of a set? After that, what is the subset? After that, what is the Cartesian product? After that, what is the relation? After that, what is the function? So first of all, you know about before going to start a function, these definitions are know these definitions. What is the set? What is the subset? What is the Cartesian product? What is the relation? After that, functions. Let us discuss first of all what is the set. Set is nothing but you know very well a well-defined collection of objects. A well-defined collection of objects. A well-defined collection of objects is nothing. A well-defined collection of objects is called a set. An object in a set is called element. You know very well an object in a set is called element. An object in a set is called element, and a collection of for example, best example in a set is collection of natural numbers. Collection of natural numbers is nothing but set. Best example is collection of natural numbers. Natural numbers are all counting numbers. Next, what is the subset? Subset is nothing but, what is the subset? For example, let A and B are be two sets. Let A and B be two sets. Then A is said to be subset of B. A is said to be subset of B. Then A is said to be subset of B. Then A is said to be subset of B. That means if every element in A, if every element in A is an element in B, every element is an element in B. If every element in A is an element in B, then only A is subset to B. So one formula is there. Number of subsets of A is equals to 2 to the power n of A. That means, for example, A is equals to set 1, 2, 3. So number of subsets is nothing but n of A is equals to 3, 2 to the power 3. So your total 8 subsets of A. In set A is equals to 1, 2, 3. Next, what is the actual definition of Cartesian product? So let us discuss this definition. Cartesian product is nothing but Cartesian product. Cartesian product here also let A and B are two non-empty sets. Let A and B are two non-empty sets. The set of all possible ordered pairs. The set of all possible ordered pairs formed by the elements in A and B. Formed by the elements in A and B is called Cartesian product of two sets. Is called Cartesian product of two sets. Then that means it is denoted by A cross B. Read it as A cross B is equals to set X comma Y, ordered pair X comma Y such that X belongs to set A and Y belongs to set B. So your number of A cross B, n of A cross B is equals to n of A into n of B. So A cross B is not equal to B cross A. N of A cross B is equals to N of B cross A. So next relation. For example, now I am discuss for example here. A is equals to one of the set 1 comma 2. B is equals to one of the set A comma B. So what is A cross B? 1 comma A, 1 comma B, 2 comma A, 2 comma B. Next, what is B cross A? A comma 1. What is A cross B cross A? A comma 1, A comma 2, B comma 1, B comma 2. It is clear that A cross B is not equals to B cross A. N of A cross B is equals to N of B cross A. So here A cross B, let us consider, for example, let us consider A is equals to set 1 comma 2 comma 3. B is equals to set 2 comma 3. So what is you are asking to find? A cross B is equals to dash. So A cross B is equals to 1 comma 2, 1 comma 3, 2 comma 2, 2 comma 3, 3 comma 2, 3 comma 3. So here is A cross B. Next, let us discuss relation. Relation is nothing but every subset of A cross B is called, every subset of A cross B is called a relation from A to B. Every subset of A cross B is called a relation from A to B. In this here, let us assume one of the relation R is subset of A cross B. Then R is called relation from A to B. Relation from A to B. Here in this example, same example here. Here F is equals to one of the relation 1 comma 2, 1 comma 3, 2 comma 3. This is subset to A cross B. Subset to A cross B. Similarly, let us assume one more G is equals to 3 comma 2 and one more H is equals to 2 comma 2 and 3 comma 3. So here also these two also subset to A cross B. This is also subset to A cross B. Here F is a subset to A cross B. G is also relation subset to A cross B. And H is also subset to A cross B. Finally, what we have to observe? Each and every subset of A cross B is called a relation. Each and every subset of A cross B is called a relation. Okay. Next, this is the relation. Next, now I'll discuss what is the actual definition of a function. In a function is nothing but a relation F from a set A to a set B is said to be a function. Is said to be a function. Another name for function, mapping. Another name for function, correspondence. If for each element small a belongs to A, there exists a unique element. Small b belongs to B, such that A comma B belongs to F. That is, for all A belongs to A, there exists unique element B belongs to B, such that F of A is equals to B. F of A is equals to B. F of A is equals to B. So finally, what is the definition of a function is nothing but if each element in A, there exists a unique element in B. A and B are two finite sets. If each element in A, there exists unique element in B. So then only a function A to B is a relation from relation F from A to B, which satisfies that condition. What is that? For every A belongs to A, there exists a unique B belongs to B, such that A comma B belongs to F. Here is the set A is the domain, set B is the codomain. Set A is the domain of the function, Set B is the codomain of the function. See, any generally relations are denoted by S, F, G, H and so on like this. Any subsets of a Cartesian product is called a relation. F comma, G comma, H and so on be the subsets of A cross B or relations of A cross B. Then F is subset are equal to A cross B, G is subset are equal to A cross B, H is subset are equal to A cross B. This is nothing but relations. Okay, so all consider one example I discuss. Now small example. A is equals to 1, 2, 3 and B is equals to 2, 3. So you know A cross B 1, 2, 1, 3, 2, 2, 2, 3, 3, 2, 3, 3. Consider the one of the following relations. Say F is equals to 1, 2, 1, 3, 2, 3. So 1 is correspondence to 2, 1 is correspondence to 3, 2 is correspondence to 3. So in this here is A, set A 1, 2, 3. Here is set B 2, 3, 1, 2, 1, 3 and 2, 3. This is nothing but F. Here is F is mapping from A to B is a relation. So yes, set A is domain, set B is codomain. One note point here, observe clearly. All relations need not be a function. All relations need not be a function. All relations need not be a function. So one of the example I'm discussing, for example, set A 1, 2, 3, set B A, B, C, D. 1 is associated A, 2 is associated B, 3 is associated D. So whether it is here is a mapping F, whether it is a given function, this is a function or not. Every element in A is associated with unique element in B. Yes, every element in A set is associated with unique element in B. Unique element in B. So F is a function. F is a function. So F is equals to 1, A, 2, B, 3, D. Okay. Next, one more example. Now let us discuss one more example. Set A 1, 2, 3. Set B A, B. 1 is associated with A, 2 is associated with A, 3 is associated with D. Here is G. Here is G is equals to 1, A, 2, A, 3, B. So here also A is a function. Every element in A is associated with unique element in B. Yes, this is a G is a function. Next, one more example. Here is a set A 1, 2, 3, 4. Here is a set B A, B, C, D. 1 is associated with A and 1 is associated with B also. 2 is associated with D and 3 is associated with B. 4 is associated with D. So here is H is equals to 1, A, 1, B, 2, D, 3, B, 4, D. So H is not a function. Why? Because H is not a function. That is clearly 1 is associated with 2 images. 1 is associated with 2 images. One is associated with 2 images. Next, one more example. A 1, 2, 3, 4. B, A, B, C. 1 is associated with A, 2 is associated with B, 3 is associated with B. Here, F is equals to, here is mapping F is equals to 1, A, 2, B, 3, B. So, here clearly what we have to observe, here 4 is does not have 4 does not have any image in B. So f is not a function. F is not a function. So clearly, I hope understood the function. What is the actual definition of a function? Function is nothing but every element in A is associated with unique element in B. Next, some important points I'm discussing. For each one of the important note point I'm discussing here is what is the A is equals to set 1, 2, 3. For example, B is equals to set A comma B. Here n of A is equals to 3, n of B is equals to 2. Therefore, number of functions from A to B is nothing but number of functions from A to B is n of B to the power n of A. That is 2 to the power 3. Right. N of B to the power n of A. So, number of functions that can be defined n of B to the power n of A. Here is 2 to the power 3. Here is 8. Okay. Next, one of the example. Let us discuss one of the example here. Here set A contains 1, 2, 3, 4 elements and set B contains 2, 5, 10, 17 elements. Here by observation here y is equals to 2. Here is 1 is associated with the 2, 2 is associated with 5, 3 is associated with the 10, 4 is associated with the 7. So 2 is equals to 1 square plus 1, 5 is equals to 2 square plus 1, 10 is equals to 3 square plus 1, and 17 is equals to 4 square plus 1. By observation, what we have to observe? Clearly, y is equals to x square plus 1. That is the function f of x. Y is equals to f of x. Therefore, f of x is equals to x square plus 1. So, we can say f is mapping from A to B is defined by f of x is equals to x square plus 1. Next, one more definition. One more example. Value of the function. Value of the function. One more definition. Value of the function. What is the value of the function? That means the value of the function. Y is equals to f of x. Yet x is equals to a. Is denoted by f of a. It is obtained by putting x is equals to a in f of x. Putting x is equals to a in f of x. For example, let us assume f of x is equals to cubed root of x. Then f of 125 is equals to cubed root of 125. That is equals to 5. Cubed root of 125 is nothing but cubed root of 5 cube is nothing but 5. Next, let us discuss types of functions. Types of functions generally here 1 function, 1 2 function, next bijection. So many types of functions are there. Mainly these three I'll discuss. 1 function, another name for injection, another name for surjection. So many types are there. Algebraic functions, trigonometric functions, modulus functions. So many types are there. So mainly I'll discuss 1 function and 1 2 function and bijection. So what is the actual definition of 1 function? Is nothing but distinct elements in A, distinct elements of A is associated with distinct elements in B. So then only a function f A to B is said to be 1 1, or another name is called injection. So if distinct elements of A have distinct images in B, distinct elements, observe clearly, distinct elements of A have distinct images in B. Some elements are left in B, don't worry. Okay, some elements are left in B, don't worry. Yeah, main thing is distinct elements in A have distinct images in B. So how to method to check the whether given function is 1 1 or not? For example, here is f of x is equals to x square plus 2. Consider x1 x2 belongs to set A element, set A. X1 x2 two elements are belongs to set A. Here is different elements in set A, different elements in set A. Now f of x1 is equals to f of x2. Then what is f of x1? x1 square plus 2 is equals to x2 square plus 2. 2 to cancel. X1 square is equals to x2 square. That means x1 is equals to root of x2 square. That implies x1 is equals plus or minus x2. x1 is equals to x2 or x1 is equals to minus x2. See here x1, clearly observe here, x1 is equals to x2 or minus x2, both have the same image. Both have same image. So clearly f is mapping from A to B is not A to R. Real number you have to take. A to R is not a 1 1, not a 1 1 or injection. So one more example, let us discuss. Example next one. F is mapping from A to set real number R defined by f of x is equals to 3x plus 5. Consider f of x1 is equals to f of x2. For all x1, x2 belongs to set A. 3x1 plus 5 is equals to 3x2 plus 5. Here simply x1 is equals to x2. So f is mapping from A to R is 1 1. So let f is mapping from A to B is a 1 1 is a function, so such that f of x1 is equals to f of x2. That implies x1 is equals to x2. Then f is mapping from A to B is called a 1 1 function. Otherwise x1 is not equals to f of x2. That implies f of x1 is not equals to f of x2. Then f is mapping from A to B is a 1 1 function. So next I'll discuss one more type, onto function or surjection. If it is not satisfies 1 1 function, if it is the function, given function is not a 1 1, then it is many to 1. Not a 1 1, it is a many to 1. So next, many to 1 function is nothing but a function from A to B is said to be many to 1 if there exists at least 2 distinct elements in set B. At least 2 distinct elements in set B. Okay. For example, here I'm discussing many to 1. If it is not a 1 1, is a many to. For example, what is the actual definition of many to 1 is nothing but f is mapping from A to B. A to B is said to be a function from A to B. A function f is mapping from A to B is said to be many to 1 function. Many to 1 is said to be many to 1. There exist at least 2 distinct elements. At least 2 distinct elements in B. In B, whose images are same. Whose images are same. For example, the mapping is, here is set A, 1, 2, 3, 4. Here is set B, is A comma P. 1 is associated with A, and 2 is also associated with A. 3 is associated with B, 4 is associated with B. Best example, f of x is equals to x square for all x belongs to R. Is a many to 1 function. Okay. So your number of 1 1 functions, one of the formula here, not point. Number of 1 1 functions from A to B, here n of B permutation n of a if n of b is greater than n of a. Otherwise, n of b is less than n of a, less than n of a, 0. A to b to d, two finite sets, the number of 1 functions. Number of 1 functions from A to B. From A to B is n of b permutation n of a, n of b is greater than n of a, otherwise 0. Here many 2 1 functions. Total number of functions minus total number of functions minus number of 1 functions. Number of 1 functions is many to 1 functions. Is nothing but many to 1 functions. For minus n of b permutation n of a. Next, clearly discuss onto function. Okay, let us discuss onto functions after session. Thank you.